Hi, in this video we are going to work on the area of triangles by using the formula with sine. So basically, in a triangle you may find the area of the triangle by using any one of the angles and the arms of the angle. Namely, the area would be 1/2 of a times b times sine alpha, where alpha is any of these angles and the lengths, the sides, are basically the arms of the angle. So if we give some numbers like the angle being 54 degrees and the sides being 7.1 centimeters and 9.3 centimeters, then using the formula I can find the area 1/2 times 7.1 times 9.3 times sine of 54 degrees, which would give me 26.709 and so on, where I cut from here for three significant figures and end up with 26.7 centimeters squared. Now the questions may also ask the angle or one of the sides, so it's going to be in reverse order. Let's see an example. We are given the area of the triangle as 42.6, and we know the arms of the triangle, the angle alpha given here. So the question is, what's the size of this angle? So basically it's going to be 42.6 equals 1/2 of 9.6 times 9.2 times sine alpha, right? Now there's no harm in calculating this bit, so when I calculate that I get 44.16, and if I divide both sides with this number, I'll get sine alpha to be 0.964 and so on, and then I can calculate alpha to be sine inverse of 0.964, and the answer will be 74.579 and so on. If I cut from here, I end up with 74.6 degrees to three significant figures. Now I calculated sine alpha. I divided this number by this number and rounded up on purpose because I would like to show you how rounding in the middle of your calculation changes the answer slightly. Now I'm going to go on from this simplification. I'm going to write down sine alpha to be 42.6 divided by 44.16. Now I can write alpha equals sine inverse of this fraction here, right? And I'm going to get alpha to be 74.725 and so on. And if I want to write it into three significant figures, then I'm going to end up with 74.7 degrees. Now you can see that the last answer I find here is more accurate because I didn't round this fraction up. In case the mark scheme says it's gonna be a number between 74.7 and 8, your answer will just not get any accuracy mark. So it's very important that you don't round your findings, your answers, in the middle of your calculation. This is very, very important. Right. Now there could be problems which requires using sine rule or cosine rule together with the area. Or it could be sine rule and cosine rule and the area of triangle. So, I mean, it could be anything. Now I'm going to give an example where we have to use cosine rule and the area of triangle formula, and then I'm going to ask you to solve the rest of the questions in the book. In the triangle ABC, AB is 14, BC is 12 and CA is 15 centimeters. So we have a triangle. So you can visualize it by sketching a triangle. It doesn't matter if side lengths are correct or not in any way. Now AB is 14, write properly, and BC is 12, CA is 15, right? So find the sides of angle C. So they're asking us to find the size of this angle with three significant figures. And then in part B we have to find the area of triangle ABC. Well, once we know the angle, we can just use the sine of that angle and the arms of the triangle. Sorry, arms of this angle. Right, so for part A, let's start with the cosine rule, right? So it's going to be right across the angle being alone, so it's going to be 14 squared equals 12 squared plus 15 squared minus 2 times 12 times 15 times cosine alpha. Now 196 equals 144 plus 225 minus 360 cosine alpha. Right, 144 and 225 makes 369, where I in the meantime swap 360 cosine alpha and 196, so it will be, well, I need some more space here, so let me take this to the other side a little bit more. This will be equal to 360 times cosine alpha. Now if I divide both sides by 360, I will have the cosine of alpha being 173 over 360, which will give me alpha being cosine inverse of this fraction. Therefore, it's going to be, now approximately, I'll just write the three significant figure rounding, 61.3 degrees. That's to three significant figures. Now I know the angle, so I can write down the area to be 1/2 of 15 times 12, the arms of the angle, and then the sine of the angle, which is 61.3 degrees. Now if I write this all together, I'm going to get 78,943 and so on, and this rounds to 78.9 centimeters squared up to three significant figures. See, we use the cosine rule and the area formula in one question. Right, now is your turn. Please go back to the blog and start solving the marked questions from the textbook and check your answers, and then please call me so that I can give feedback for your work. Thanks for watching.